Welcome to lecture 27 of the course CS213 Object Oriented Programming of the Kohat University of Science and Technology. In this lecture we will continue our discussion of strings and we will particularly focus on regular expressions and how they can be used along with the strings. The agenda for this lecture is regular expressions and the relevant material can be found in chapter 14 of the recommended book Java How to Program Early Objects version Detail and Detail. Regular expressions, before we go into the definition and explanation of regular expressions are used in almost all of the applications that we use on daily basis as programmers. For example, you use different editors: Eclipse, JBuilder, Visual, Slick Edit, IntelliJ, etc. All of these editors use regular expressions to try and understand your code and compile your code. And some of the command line tools also use regular expressions where they try to read your text and try to make sense of the text by breaking it down into different strings or expressions. But not all regular expressions are created equal. We will see that there are different types of regular expressions that we can create for different situations. Regular expressions. A regular expression is a string that describes a search pattern for matching characters in other strings. Such expressions are useful for validating input and ensuring that the data is in a particular format. For example, we have been taking input from the users. We have been be able to validate some of that input. For example, when we were working with numbers, we were able to easily validate those numbers. Maybe, for example, the simple validation of if the number should be greater than 0 or greater than a particular number. But we were not doing that for strings, since we were taking a name from the user and we were assuming that the user will enter a valid name. Like, for example, that name would not contain any other symbol or number that is usually not used in names. Although you might disagree when we see the name of the child of Elon Musk, but that is a different situation that we need to be ready for. For example, a zip code must consist of 5 digits. Here we are talking about the US zip code. Every country has their own zip code and their own pattern of the zip codes. And a last name must contain only letters, spaces, apostrophes, and hyphens. We do not usually allow numbers in our names. One application of regular expressions is to facilitate the construction of a compiler, and this is one of the most important use of the regular expressions. All of these compilers are constructed based on regular expressions. Often, a large and complex regular expression is used to validate the syntax of a program. How do compilers understand our program? How do they break down our syntax into different understandable portions? Is totally by using regular expressions. If the program code does not match the regular expression, the compiler knows that there is a syntax error in the code, and that is how our compiler works. It tries to match our code to a particular regular expression, and if it does not match with the regular expressions, we might get a syntax error. As we said that it describes text, used for pattern matching in development, mainly editors, command line tools, and programmatically. Examples can be search and replace, grep tools, and regex in languages. For example, most of the programming languages or all of the programming languages use regular expressions. Now we can use regular expressions in the class string. It does have some capabilities of using regular expressions. Class string provides several methods for performing regular expression operations, the simplest of which is the matching operation. String method matches receives a string that specifies the regular expression and matches the contents of the string object on which it is called to the regular expression. We will see an example in a while. The string class has a matches method that can be used to match a certain expression or with a string or with an object of the string if we want to maybe for example validate that string according to a regular expression. The method returns a boolean indicating whether the match succeeded. Let's say for example you want to verify an email address in the form as is given first name underscore last name @ somewhere.org without regular expressions. Now we have dedicated classes for using regular expressions, but we will try to use regular expressions that is provided by the strings class. We will need to check for the @ symbol within this expression. We will need to check that the end of the string has .org at the end. Check for an underscore with letters before and after it. So this might become very complex when we are not using the dedicated regular expressions. For example, we will look at in an example that how we can define a regular expression for validating our email. This is an example of a regular expression where these brackets will provide us that we are trying to or expecting a character between capital A and small and capital Z and small a and small z. So anything an English alphabet will be acceptable whether it is in capital or small letters. The plus symbol indicates that there must be at least one letter at the start of our email address. So we are not allowing email addresses that are starting with numbers or any other symbol other than the English alphabet A to Z in capital and A to Z in small letters. Then we are expecting an underscore after the first word, so we will get a first word in all English characters, followed by an underscore, followed by another set of English characters. There must be at least one character after the underscore and one English character before the underscore. And there then must be an @ symbol. So we need to have an @ symbol in our email address. The @ symbol will be followed by at least one English alphabet, whether be it in capital or small, both of these are acceptable, but there must be at least one, and that is shown by the plus symbol. The plus symbol shows us that there must be at least one or more. So if we want to ensure that there must be at least one or more characters at a certain location, then we can use the plus symbol, and that must then be followed by the .org. We are using the double slashes because the dot may be used for other identifier as another other identifier in a regular expression. That is why if we want to check for a literal dot, we will need to use the double slash symbol, and org will be then checked. If the email dot matches this regular expression, now matches is a method of the string class. Email is our string, matches is a method of the string class, and if our email matches this expression, that is that we have the expression that we have defined, then do something. Regular expressions allow you to exactly and succinctly define matching patterns. Patterns describe text rather than specifying it. We do not exactly write the email that we want to check, but we have provided a pattern that describes the type of the emails that we are expecting from the user and how or what criteria those email addresses should follow to be valid. This can be read as an example application of the situation that we are trying to validate over here. We are trying to validate an email address, and in this case we have a regular expression. Then we have a set of email addresses that we would want to validate according to this expression. And what we do is we go through the array. We have an array of email IDs. We go through the array one by one and we check if our email IDs match or if any of the email ID matches this pattern that we have defined. If it does, we print it matches, and if it does not, we print that it does not match. Now, to look at an example of how we can use the methods of the string class to perform some validation and use regular expressions, we have this example from the book where we are trying to validate the first name, and we want to ensure that the first name should follow a certain pattern, and that pattern is that we want the name to be an English alphabet. We want the first name to be an English alphabet, and that is why we have this validation class, and we have static method in that class. It should return a true if our first name matches this pattern, and a false if our first name does not match this pattern. Now let's look at this pattern a bit closely. The pattern allows us to match a set of characters that does not have a predefined character class. We use these square brackets. So we use the square brackets to ensure that we want a certain type of a character at this location. The square bracket will provide validation for only one character, and if we want to increase the number of characters, we can include this asterisk symbol. Now in this example, the A to Z matches a single uppercase letter. This one, it will match a single uppercase letter, and it will, so we are ensuring that the first letter of our first name will always be a capital letter, and that is what we are ensuring through this regular expression. That letter can then be followed by capital or small English alphabets, and now this expression ensures that we will have at least exactly one letter, first letter, and this one, the next one, we can have zero or many. The asterisk is for zero or many letters. So we will have first letter and our first name that will be in capital, and that letter may be followed by another set of alphabets, or it may not be followed by any alphabets as well, and that is due to this asterisk symbol. This asterisk symbol ensures that whatever is followed by the whatever is there after the first letter, it must be an alphabet, or there may not be any alphabet at all. Now to look at the last name, to validate the last name, we are allowing the small and capital letters as the first character in our last name, as we can see over here. Now you can see this one is a small z, so this will allow any characters that are there based on their ASCII positioning, ASCII numbering. If you want to know more about the ASCII numbers, you can look at the appendix of the book, where appendix B of the book, where you will be provided the ASCII values of different characters. So it will match any character that is there between the capital A and the small z. This will include all the alphabets from capital A up to capital Z, and then it also matches those characters that are there between the uppercase Z and the lowercase a. And there must be at least one character in our last name. If we do not enter any value for our last name, the compiler will complain because it is expecting at least one character for our last name. Then we can allow space in our last name. We can allow a hyphen, an apostrophe. We can allow a hyphen in our last name, but these characters can only be after our first alphabet, and then that these characters must be followed by any English alphabet from A to Z, whether capital or small, and we would have at least one or more characters. So we are not allowing the last name to have a hyphen, an apostrophe, or a space at the end of the name. If there is an apostrophe, for example, there are names that might have apostrophes like O'Keefe or something like Smith, John. So we might have names where we have a hyphen, but whenever there is a hyphen, for example this one, this will not be allowed. Whenever there is a hyphen at the end, there must be at least one English alphabet following that hyphen or that apostrophe or that space. And we can see that this has been grouped together and then it is followed by an asterisk symbol. Now we can group our regular expressions between these parentheses, and this will now check that there might be an occurrence of this type of an expression, or there might not be any occurrence of this type of expression. But if there is an occurrence of any expression after the first letter in the last name, that must follow this pattern. But the asterisk symbol tells us that if we have only one character for our last name, that can be valid. But if we want to add more characters along with the first character, then those characters should follow this pattern. And that is what the asterisk symbol tell us, that there might be either no characters or there might be many characters, but those characters will be following this pattern, and we have grouped this pattern, for example the pattern for the symbols and the pattern for this character alphabets, into a single regular expression. Next we are validating the address, and the address must follow a certain pattern. For example, let's say we have an address usually like 13 Kohat Road. Now the 13 is our house number and this one is maybe the street number or the road that we are living in. If you look at this address, now this address is expecting an integer value first thing in our address string. The D over here is for the integer. It is a group of integer, and we will look at a table where we have these groups of characters or character classes. The D is for integers. So we must have at least one integer at the start of our address, as is shown by the plus symbol. Again, we are using the double backslashes. Now the next thing is S. This will be for white space characters, and over here we are expecting that we will have a space after the number. So we will enter a number that is an integer value, that must be followed by at least one space. As we can see, there must be at least one space. It can be any white space character, but here we are expecting it to be a space. Then the space must be followed by, as we can see, we are creating a group over here again, that must be followed by English alphabets, and there must be at least one alphabet. So if we do this, we are okay over here. It can be a capital letter or it can be a small letter, and we can have at least one or more alphabets over here. You can see. And if you look at this symbol, this tells us an R. This is an R symbol that we can use in regular expressions. Now it is telling the compiler if we enter this address, then, or if we enter this address, both of these will be okay. And the reason for that is that we are using an R symbol. Now this expression up to this point will validate this address. And if we want to allow more than one word in our address, we can tell the compiler that if the user enters one word after the number, or if the user enters two words after the number, then both of these addresses should be okay. So we are validating two words over here separated by a space. So the second word, so this will validate this second address, that we can have a word that is A to Z, capital or small, separated by a space, and word capital Z or small, from capital A to capital Z or small a to small z, and there must be at least one character. Next we are validating the name of our city. Now some cities can be one word or some cities can be two words. For example, if we are using one word, then we are okay with this expression. But if you have two word cities like Toba Texing, etc., or Dera Ismail Khan, there that has three words, then we can create a regular expression for that validates three words, and all of those words should be in English alphabets according to this expression. You might have expressions that are different than this one according to your needs, and exactly the same expression will be used for validating the name of the state. Now you can imagine what can be an expression for validating the name of Khyber Pakhtunkhwa. For the zip code, we have now this expression tells the compiler that there must be exactly 5 integers in this expression. If the string has 5 integers, that will be a valid zip code, otherwise it will be an invalid code. So the D is for integers, and this 5 between curly brackets is for ensuring that we have exactly 5 integers. So if you want to ensure that exact number of characters in an expression, then we can use the curly brackets to ensure that we have exact number of characters. We'll look at this in a later slide as well. And similarly, we can provide ranges. If you look at the phone number, now the phone number 1 to 9 tells the compiler that the first character in the phone number must be a non-zero number, as in this case. This is a US phone number. you can imagine that in our cell phones we always have a 0 at the start of our cell phone numbers. So we can, if we are trying to write the regular expression for our phone number in Pakistan, let's say, so the first letter should be, or the first character should always be a 0, and then we understand that the second character or the second number in our phone numbers is always a 3. So this is the kind of an expression that we'll be using for the first two integers or characters of our phone numbers. This one over here tells the compiler that the number should be between 1 and 9. If you are writing it for the Pakistani phone number, you can say that the number should be between 0 or 9, or we can simply say that we have 03, then we have 333 or 345. So that is followed by exact two integers, and those integers can be any numbers from 0 to 9. Then we have a separator, that is the hyphen between those numbers, and if you can imagine what is the exact number of digits in our phone number, if I can guess it right, I think we have 7 digits in our phone numbers. Now you might want to add more details to it, but if you want to simplify, this can maybe possibly validate our cell phone number. You can try it for the CNIC number to validate the CNIC number, or any other numbers that are standard and cannot be changed and need to be entered as it is. So for the US phone number we have this: the first character should always be a non-zero, the second can be two digits, and then separated by a hyphen, then there is a non-zero number, then the two digits, and then there can be any four numbers, but exact four numbers. We cannot have less than four numbers at this position, less than 1 plus 2 3 numbers at this position, and 1 plus 2 3 positions in this position. Similarly, we have four digits at the start of our phone number there, and the first one is always a 0, the second one is always a 3, and then we have 7 digits after the separator. Now what happens is that this program takes input from the user one by one and tries to validate each of their input, and we are doing this by calling each of the method. So if the first name is not validated, if a false is returned, we have invalid first name, we have invalid last name, and we try to validate all of our data. If I try to run this, you can get this program in the book, and it will also be uploaded as well, so you can practice it. So let's say I have a first name, and the first name is expecting me to have the first letter as capital. If I'm being careful, the last name can have any characters, maybe matching a certain pattern. I will enter uh, an address. The city is Peshawar, maybe it is, the state is KPK, or maybe Pakistan, whatever you want to enter. The zip code is 2500, and let me enter maybe an invalid number. If I enter a number that is not according to the pattern, maybe, so you can see that it has written with an invalid phone number. The rest of the details are valid. You can try different values and see if you are getting the accurate results. You can change the patterns and try different values as well. And to look at the simple rejects that we tried for our email address, now if we look at these email addresses, we have a string of we have an array of our email addresses, and we are trying to match those email addresses with the pattern that we have defined already. If I run this one, it tells me that Hamid underscore Zahur at the KUST.org matches the pattern. If I see, look at over here, look at this pattern over here, the pattern is anything that is between capital A to Z and small a to Z is a valid name or username, and that name must be separated by an underscore. So this one and the second one are valid, but the third one, since it does not have an underscore, is not a valid email ID. And this is also a .com. If I try to change this one to .com and I try to see and try to maybe change the case of this one and try to run it again. So the first one matches irrespective of the case of the alphabet. As you can see, we are allowing both of these two alphabets, but the other two do not match. The reason for this one is it is expecting an org at the end of the email ID, and it is also expecting an underscore in my user name.